Good morning, everyone, and welcome to our first video in learning differential calculus. So in order to master differential calculus, it is essential to start with other more basic topics, such as exponents, radicals, trigonometric functions, and we will cover a few of these topics today. Today we will start with exponents. So many of you might have learned this in high school, maybe take this as a review. First of all, when we have x to the power of a, it is important to know that x is the base and a is what we call the exponent. So I just wanted to note that if f of x equals to x squared, where x is the base and 2 is the exponent, this is what we call a quadratic. However, if 2 is the base and x is the exponent, this is what we call an exponential function. So please keep this in mind for a later part of this course. Now we will move on to a few exponent rules. X to the power of a times x to the power of b, since the base is the same, we can add up the powers, so this is x to the power of a plus b. Now x to the power of a divided by x to the power of b, since the base is the same, we subtract the powers, so x to the power of a minus b. Now x times y all to the power of a, each of the x and the y become to the power of a, so we get x to the power of a times y to the power of a. X divided by y all to the power of a gives us x to the power of a divided by y to the power of a. Now x to the power of a all to the power of b, we multiply the powers, this gives us x to the power of ab. We can also write this as x to the power of b all to the power of a. Now what if we have a negative in the exponent? What we do is we flip the fraction, the denominator becomes the numerator and the numerator becomes the denominator, all of that to the power of a. And we did something similar in a previous property. This becomes y to the power of a divided by x to the power of a. Now what if the negative is in the base? Negative x all to the power of n is x to the power of n if n is even, and negative x to the power of n if n is odd. Finally, x to the power of 0 is 1. So in order to practice all of these exponent rules, we will move on to a few examples. I just wanted to note that when I write a book or page number in dark blue, this number means that these exercises are taken from the page, from the book at this page. So our first example, 3a cubed b cubed times 4ab squared all squared. So I will start by making the 4 squared, the a squared, and the b squared, I will square it too. So 4 becomes a squared, the a becomes a squared, and the b squared all squared. Next, I will write the 4 squared as 16, a squared, b squared all squared is the same as saying b to the power of 2 times 2, so b to the power of 4. Now I have a 3 and I have this 16, I multiply them, I get 48. A cubed times a squared, this is the same base a, we add up the powers, so 3 plus 2, which is 5. Finally, b cubed and b to the power of 4, we add up the powers, 3 plus 4 is 7. Our next example is the following, 3x to the power of 3 halves times y cubed divided by x squared times y to the power of negative half, all to the power of negative 2. So as I mentioned before, when we have a negative power, we can start by flipping the fraction. So the denominator becomes in the numerator, and the numerator becomes in the denominator, all of that squared. Next, the numerator becomes squared, and the denominator also becomes squared. Next, each term inside becomes squared, so x squared all squared times y to the power of negative half all squared divided by 3 squared x to the power of 3 halves all squared y cubed all squared. So x squared all squared, this is x to the power of 2 times 2. We multiply the exponents. 2 times 2 is 4. Same for the y. Negative half times 2 is negative 1. Now in the denominator, 3 squared is 9. X to the power of 3 halves times 2 is x to the power of 3. Y to the power of 3 times 2 is y to the power of 6. So now as you can see, I have an x in the numerator and in the denominator. I can write this as x to the power of 4 minus 3. I subtract the exponents because we have a division here. 4 minus 3 is 1. Now for the y, I can write this as y to the power of negative 1 minus 6, which is negative 7. And I keep the 9 in the denominator. Now I can rewrite this as x divided by 9y to the power of 7, and this is our answer. So now we will move on to absolute values. So I will start by telling you that the absolute value is a distance, and the distance is always positive. So the absolute value of 5 is the distance between 5 and 0 on the number line, and the absolute value of negative 5 is the distance between negative 5 and 0 on the number line. And as you might notice that the distance between 5 and 0 and the distance between negative 5 and 0, they're both equal and they're equal to 5 units. So absolute value of 5 equals to absolute value of negative 5, which is equal to 5. Now, if we're told that the absolute value of x minus 3 is 2, this means that the distance between x and 3 is 2. If we are told that the absolute value of x minus 3 is less than or equal to 2, this means that the maximum distance between x and 3 is 2. Now we will look at a few techniques to solve expressions with absolute value. So the absolute value of a is equal to a if a is positive, and it's equal to negative a if a is negative. For example, absolute value of 2, where a is equal to 2, is equal to a itself. So it's equal to 2 because 2 is greater than 0, so 2 is positive. Now absolute value of negative 2, a is equal to negative 2, and it is negative. So the answer is negative a. So negative of negative 2, we have two negatives, this becomes positive 2. Now we will simplify the following expression, absolute value of 3x minus 3. This is equal to, so a is 3x minus 3. This is equal to a, so it's equal to 3x minus 3 if a is positive. So if 3x minus 3 is greater than or equal to 0. If we were to solve for x is greater than or equal to 3 over 3. So x is greater than or equal to 1. However, it is equal to negative a, so negative of 3x minus 3, which is negative 3x plus 3, if a is negative or less than 0. So if we were to solve for x is less than 3 over 3, so x is less than 1. Now we'll move on to reviewing roots, radicals, and rationalization. So let's start with the root laws. Before that, I just wanted to point out that the nth root of x, another way to write this is x to the power of 1 over n. And whenever we have square root of x, and a square root n is equal to 2. So this is x to the power of 1 over 2. So nth root of x times y is the nth root of x times the nth root of y, which is x to the power of 1 over n times y to the power of 1 over n. Now the nth root of x divided by y is the nth root of x divided by the nth root of y, which is x to the power of 1 over n divided by y to the power of 1 over n. And we can rewrite this as x times y to the negative 1 all to the power of 1 over n. Now, the mth root of the nth root of x, it's always good to start inside the inner root. So the nth root of x, as I previously showed you up here, the nth root of x can be written as x to the power of 1 over n. So x to the power of 1 over n. And now we would like to take the mth root of that. So all of that to the power of 1 over m. Now using exponent laws, we can multiply the exponents, so this is x to the power of 1 divided by nm. And we can write this, if we want, as the nmth root of x. So using these laws, we will move on to an example. We would like to simplify square root of x to square root of x. So, as I said, let's always start inside. So x times the square root of x. Square root of x, we can write that as x to the power of half. Now using exponent laws, this is as if we have x to the power of 1 times x to the power of half. We have the same base, so we can add up the exponents. 1 plus half is 3 halves. So now we have x to the power of 3 halves all to the power of half. And again, we can use exponent laws. We can multiply the exponents. This becomes x to the power of 3 halves times half, which is x to the power of 3 over 4. Now, we did all of these laws with roots and radicals. What if we want to get rid of these radicals? To get rid of them, this is what we call rationalization. So if we are given a plus square root of b, if this is our term, we can multiply it by what we call the conjugate, in this case a minus square root of b, and we get a product a squared minus b that has no square roots in it, or no roots. Square root of a plus b times the square root of a minus b is a minus b squared. Also, square root of a plus square root of b times the square root of a minus square root of b is a minus b. Now the nth root of a times a to the power of 1 minus 1 over n is a. Now I will just show you a few of these, just for you to see how they work. So the first one is a plus square root of b times a minus square root of b. This gives a squared minus a square root of b plus a square root of b minus b. I cancel a square root of b, so this becomes a squared minus b, as I already wrote. So another example, I will show you the last one. So as we discussed earlier, nth root of a, we can write this as a to the power of 1 over n. And since we have the same base, we can add up the exponents. So 1 over n plus 1 minus 1 over n. We cancel the 1 over n. This becomes a to the power of 1, which is a. So an example might be if we have square root of 2. Square root of 2 is 2 to the half. If I multiply that by 2 to the 1 minus half, this is as if I'm saying 2 to the power of half times 2 to the power of half. We add up the exponents. It gives us 2 to the power of 1, which is 2, and you can see there is no square roots in that. So in case any of these formulas threw you off, we will move on to a few examples, but before that, I just wanted to give you the general way of writing these formulas. And now we will do some examples. So our first example is f of x equals to square root of 10 divided by square root of 5 minus 2. We would like to rationalize the denominator. So this is as if we have square root of a minus b. So first I will rewrite the expression. This is square root of a minus b. I will multiply it by square root of a plus b. So I will multiply the denominator by square root of 5 plus 2, and I will also multiply the numerator because in order for this equality to stay true, I should multiply both the numerator and the denominator. Now with the numerator, we get square root of 10 times square root of 5 plus 2. In the denominator, I get square root of 5 times square root of 5 plus 2 square root of 5 minus 2 square root of 5 minus 4. So in the numerator, square root of 10 times square root of 5 plus 2 square root of 10. In the denominator, I can cancel out 2 square root of 5. I get square root of 5 times square root of 5, which is 5 minus 4. Now the numerator, I can rewrite the square root of 10 times square root of 5 as square root of 50 plus 2 square root of 10. Denominator becomes 1. Square root of 50, I can rewrite this as 5 square root of 2 plus 2 square root of 10, and this is our answer. Now I will move on to another example. So first, as I said, we rewrite the expression. This is square root of a minus square root of b. I will multiply it by square root of a plus square root of b. So I multiply the numerator and the denominator. So this will give square root of a minus square root of b times the square root of a plus square root of b gives a minus b. So we will get x plus h minus b, b is x, divided by h times the square root of x plus h plus square root of x. So on the numerator, we cancel out x minus x. We get h divided by h times the square root of x plus h plus square root of x. We can cancel out the h as long as we take the restriction that h is different than 0. And our final answer becomes 1 divided by square root of x plus h plus square root of x. Now we will move on to rational expressions. Please note that with rational expressions, in order for the function to exist, the denominator should not be 0. And also, we will have another video about functions to clarify this idea. For now, let's simplify this. We will factor the 2 in the numerator, and we get x squared minus 3x minus 10. And in the denominator, we get 2 times x squared minus 25. Now, if we want to factor the quadratic in the numerator, we get x minus 5 times x plus 2. There are several techniques for factoring. In this case, if you notice, negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. And for the denominator, so just to note that a squared minus b squared is a minus b times a plus b. And x squared minus 25 is x squared minus 5 squared, so it's equal to x minus 5 times x plus 5. So the denominator becomes x minus 5 times x plus 5. Now we cancel out the 2, we cancel out the x minus 5 as long as we take the restriction that x minus 5 is different than 0, so x is different than 5. And our final simplified answer becomes x plus 2 divided by x plus 5. So again, we will have a different video to explain factoring thoroughly if you are having trouble with it. And for now, I would just wanted to let you know that these are fractions. We can multiply fractions, so x divided by y times m divided by n. We multiply the numerator, gives us mx. We multiply the denominators, gives us ny. If we had x over y divided by m over n, this is x over y times n over m. We get nx divided by my. So we will use all of these techniques in the following exercise. So if we are told that f of x equals to 2x squared minus x minus 1 divided by x squared minus 9 times x plus 3 divided by 2x plus 1. So we would like to simplify this. First, we have a multiplication here, so I will multiply the numerators and we will multiply the denominators. So one thing we can do with the x squared minus 9, as we saw earlier, a squared minus b squared is a minus b times a plus b. So we can write x squared minus 9 as a minus b times a plus b, where x squared minus 9 is x squared minus 3 squared. So a is x and b is 3. And I multiply this by 2x plus 1, and I will keep the numerator the same for now. Now the numerator, I will start by factoring this quadratic that we have. So I will start by factoring out the 2. I get x squared minus half x minus half. As you can see, a is equal to 1, b is negative half, c is also negative half. So b squared is negative half all squared, which gives us 1 over 4. 4ac is 4 times 1 times negative half, which becomes negative 2. Now square root of b squared minus 4ac is square root of 1 over 4 minus negative 2, so plus 2, which is equal to square root of 9 over 4, which is 3 over 2. Now I will use the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a. b is negative half, so negative b is half, plus minus 3 over 2 divided by 2a, since a is 1, so 2a is 2. Half plus 3 halves divided by 2, you can plug this in on your calculator, you get 1. And half minus 3 halves divided by 2 gives us negative half. And these are our roots. Since they are roots, don't forget to put a negative sign when factoring. So 2 times x minus 1 times x plus half times x plus 3 divided by x minus 3, x plus 3 times 2x plus 1. And now it's time to start canceling. So we can cancel x plus 3 and x plus 3 as long as we take the restriction. I will write the restrictions here at the bottom. That x plus 3 is different than 0, so x is different than negative 3. So now I will continue simplifying. So I will try to factor out the 2 from 2x plus 1, and this gives me x plus half. Now I can cancel out the 2's, and I can cancel out the x plus half, as long as x plus half is different than 0, so x is different than negative half. And our final answer becomes x minus 1 divided by x minus 3. Now we will move on to exponentials and logarithms. So, exponentials, first of all, the graph, if a is greater than 1, is the graph in purple, but if 0 is less than a less than 1, we get the graph in dark blue. The domain is x belongs to R, all real numbers, and the range, as you might see, is y is greater than 0. Again, we will have another video to dive deeper into functions. But for now, please keep in mind that exponentials, as I have mentioned earlier, the base is a and the exponent is x. So maybe like an example is 2 to the x. Now for logarithms, log base a of x, the graph if a is greater than 1 is shown in purple, and the graph if 0 is less than a less than 1 is shown in dark blue. The domain is x is greater than 0 and the range is all reals. Now I just wanted to point out too what a logarithm is. So log base 2 of 8. The answer is 3. Why is that? We put the base first. We say 2 to the power of what is 8? And we know that 2 to the power of 3 is 8. So the answer to log base 2 of 8 is 3. So we'll use this, what I just told you, in order to figure out some properties of logarithms. So log base a of a, we say to ourselves, a to the power of which number is a, and we know that this is 1. Log base a of 1, a to the power of which number is 1, and we know that any number to the power of 0 is 1. Now here are some other properties you should know. Log base a of big A plus log base a of big B is log base a of a times b. Log base a of big A minus log base a of big B is log base a of a divided by b. So the addition becomes multiplication and the subtraction becomes division. Moving on, log base a of a to the x is x log base a of big A. This is not the same as what I'm writing right now. Don't mess up the notations. Now log base a of b, let's say I would like to change the base and I want the base to be c. This becomes, I can write this as log base c of b divided by log base c of a. This is to change the base. Now log base a of a to the k, again, a to the power of what is a to the k, and the answer is k. Now a to the power of log base a of k is also k, and these are the properties of logarithms.